All right, pre-calc, this is the third part of the section 1.3, multiplying of polynomials, factoring polynomials, simplifying the expressions involving those. And I have two very terrifying looking examples that are thrown before you. And the reason why I even went to those examples was because I found that they are super helpful for kind of ushering in really an idea that you'll see in calculus. Not really an idea, but it kind of like it makes some of the calculations for calculus a lot more gentle because it's like, oh, once I figure out that this mess actually has a very elegant solution, we'll be all the better for it. So, number 81. Yikes. Okay. 3x plus 1 to the 6th power times a half times 2x minus 5 to the negative 1/2 power. That's a little bit interesting for a polynomial expression. I guess it's not a polynomial expression. It's just an expression. Times 2 plus all of this. So this is where you got to think a little bit outside the box. This right here is one long interconnected product. They're all multiplied together. Okay? As is this. So hopefully you guys are piecing together that, hey, the first string of product seems to share some stuff with the second. There's a 3x plus 1 quantity here. There's a 3x plus 1 quantity there. There's a 2x minus 5 quantity here, and there's a 2x minus 5 quantity there. So here's what I want to do. Before we jump into this wreck right here, let's just do a little investigating of a simpler looking thing. So let's, instead of saying let 3x plus 1 be what it is, let's just say A represents the 3x plus 1 quantity. All right? And it's being taken to the 6th power. I'm going to ignore the 1/2 and the 2 here. Well, you know why I can ignore the 1/2 and the 2? Because if I use the commutative property, 1/2 times 2 is 1. So we can actually scratch those out. Can't do that over here, but that one for sure is okay. I'm going to call 2x minus 5 b, and it has a negative 1/2 exponent. So you got a to the 6, b to the negative half, and now you've got, that's the b, right? I said that 2x minus 5 was b, plus b to the half, a to the 5th power. And again, I'm just going to ignore the 6 times 3. This is just kind of going aside and thinking through this. If you had to factor that, what's the idea behind factoring? Well, you take out what they share. This and this shares an a to the 5th power. That means I can divide both quantities by a to the 5th and bring it out front. Similarly, these both share something. Now it's hard to see that when you have a fractional exponent, but when you compare it to the a's, we took out the smaller of the a's. We took out the a to the 5th. Which of these is the smaller of the two? B to the negative half. So I'm factoring out the smaller part that both of them have. And then when I do so, this just becomes a plus, what's 1/2 minus negative 1/2? Two halves, 1. It's b to the 1. Oh, so that's what's going on here. Extend it to what's happening here. and we're factoring out a 3x plus 1 to the 5th power from both of these parts, which essentially, like, once you factor it out, it's gone in one part, and then it changes this 6 exponent to a 1. And then similarly here, 2x minus 5 to the negative half power is factored out, which means that whole quantity is factored out. But then you're saying, but the 1/2 changes now to a power of 1. So I just like scribbling it out. It's 1 now. Now I'm going to put a bracket here and try to sort of collect what's still left over. So in my first term, the 2 times the half is a 1. This became a 1 as well because I factored it out. There's a 3x plus 1 hanging around. Over here, the 3x plus 1 to the 5th power is gone. 6 times 3 is 18. So it's 18 times 2x minus 5. I can just put it down here. Plus 18 times 2x minus 5. So now, moving forward with what we see here, it's basically a string of products. The negative exponent now can occupy the denominator of the fraction. We can kind of create a fraction here that has the negative 1/2 exponent. Yeah, that whole power can just be, sorry. Having trouble talking right now. 3x plus 1 to the 5th power, bam, stays on the top of the fraction. This one can go to the bottom, though, and be rewritten as a positive exponent. And then inside here, we can just simplify it. So it's 3x plus 1 plus 36x minus 5 times 18 is 90. All right. Combine like terms, 39x. 1 minus 90 is a negative 89. So don't get me wrong. This is not the heart of calculus. This is just saying we can take a pre-calc concept, the idea of factoring, and apply it to something that is just really, really intimidating right there. Let's see if we can do it now with the new example. That works. All right, so check the space. Oh, did I write this down incorrectly? No, I got it. It just looks a little funky. The 2 parts of the numerator are the ones that we're trying to figure out if they factor. This one has a 4x squared plus 9 to the half. This one has a 4x squared plus 9 to the negative 1/2. You can take the negative 1/2 power out of there. Like, you can factor it out just like we did over here. So I am going to take this 4x squared plus 9 to the negative half, and we're saying it's being factored out of this, so that's gone completely now. And when it gets factored out of this, remember, we just take the 1/2 and subtract it. Factoring is division of the thing you took out. And division here means the same base, 4x squared plus 9, and then you subtract the exponents, leaving you with 1 left over. And there's a 2 here, and a, kind of like a 2 there with my 8x. So I can factor this 2 out and say, well, that 2's gone. I factored it out. And then this 8, you just say it's 8 divided by 2. So that gives me 4x. So now we've got 4x squared plus 9 remaining in that first part. And then we've got, this is where you got to kind of move around with your multiplication. Half times 4x is 2x. So it's minus 2x plus 3 times a half times 4x, which is 2x. And I'm going to refrain from rewriting the denominator. I'm just going to figure out what that numerator is first, then we'll incorporate the denominator. So 2x times 2x is 4x squared, and this is going to be 6x. There's a minus being threaded through the whole thing, though. So this is off to the side. Hopefully we can still see that. 4x squared plus 9 minus 4x squared minus 6x. So the 4x squareds just completely cancel out. So we had 4x squared plus 9 to the negative half. That whole thing just reduces to 9 minus 6x. Which technically there's a 3 in the 9 and a 3 in the 6. We could factor that out too. Factor a 3 out of here, and what does this become? 2 times 3. 6. Make sure you divide out. So 9 divided by 3 is 3. 6 divided by 3 is 2. And now you've got a denominator of 4x squared plus 9. Oh yeah, and it's to the half squared. Remember, a power to another power, you just multiply those together. So a half times 2 is 1. So it's over 4x squared plus 9 to the 1 power. And then here's the great part. There's still one more move to make. This power and this power can consolidate. Because again, if you are dividing powers with the same base, it's just like subtraction. So you're going to take negative a half minus 1. Negative a half minus 1. It comes out to be negative 1.5 or negative 3 halves. Negative 3 halves is the more appropriate way to talk about it generally in the math, the math academic community. So that's what happens when we divide 4x squared plus 9 to the negative half over 4x squared plus 9 to the 1. It becomes 4x squared plus 9 to the negative 3 halves power. I'll write that out for us. And really, when we see something like that, we should think to ourselves, shouldn't that just be in the denominator and made positive 3 halves? And the answer is, yeah, it should be. So our final answer is 6 times 3 minus 2x, all divided by 4x squared plus 9 to the 3 halves. And 81 and 89 are, for all intents and purposes for this pre-calc class, total beast problems. So don't look at this and be like, how many of those are you going to make us do? Probably just a couple here for exposure. Probably not that intense for like a test type situation. All right, guys. Thanks for watching. That's section 1.3.